Okay, so these are the homeworks. So I figured I'd sort of poke at it and go through. So this thing is due, I think, Sunday night. And so now, of course, there are other problems too, but I thought it looks as though I've given you a lot of, well, with a few exceptions, a lot of practice on these, maybe over practice on some of them.
On this one, I had a question.
What's it?
Did you mean to have two problems on the same board?
Yeah, I mean, I thought, it just seemed like it took up a lot of the page, though, didn't it?
I didn't work.
Okay. But here we can start it and go backwards. Start on that one. So might as well. Here, wait a minute. Let's see now. So what I'm going to be doing is scratching on the OneNote. So you can go to Blackboard and download, and there'll be a PDF. But you can also click the link to OneNote, and it'll draw you over to this, and you'll see a folder that has this in there. I might as well just show you. Let's see. I think I can get in Blackboard pretty quick. Well, okay. So, okay, what I'll do this and sort of monkey around with it, and then I'll show you. I'll go ahead and log in, get to our site, which I guess it doesn't matter which dynamic section I go to because they're both linked to the same. Okay, so I go to content. I hit the content button. Oh yeah, there it is. So you go down here. There's the YouTube link, but class lecture note. So what I'm gonna do is I'll just show you if I start working something. That's just to let you know that it's over there. So hang on. It takes it a second or two to sync, but you should be able to hit class notes. It probably will do this to you, make you use your tech. And I don't know if I'm supposed to put in .atu. Okay, so or atu.edu. Then it probably sends me back to this, which is the oddest thing. But that's because they pay for a license for this, and so they're paying for it for the campus, so they get a server and all this other stuff. And now that I've logged in, come on, and now here takes me to the OneNote. There should be a little tab, but let me see if I can see where the tab is. Okay, here it is. It's under homework. So when you go there, you'll see the homework. And then I guess I was playing around on the last page of homework 1. And so you can see the scribble sitting right there. So whatever I mess with here in class, that's how you get to it. Not that, but just in case there's something to jog your memory there. So here, now that I've done that, let me get that off of there. It says a roller coaster's speed. It has a speed of 25, and it's increasing. He even tells you it's AT. Determine the magnitude of the acceleration of the roller coaster at this instant and the direction angle it makes with the X. Okay, what is that doing here? So Okay, so here's the tangent. That's decent normal. So you've got acceleration in that direction, v squared over rho or r or whatever. There's your biggest annoyance, is to take this thing and go into that. What's that? Rho. Okay, I'm going to try to remember this, but there's no guarantees here. 1 plus, I think it's dy dx. Oh, that's weird. What happened there? And then I think it's, oh, that's what happened. Okay. Here, I'll tell you what. Let's do this. Oh. Okay. Here. Try this again. It's not going to let me move it. Okay. I'll tell you what. Here, I'll just, it's the 3/2 and then the square. Okay. So if you go back and look at it, let's see. Go away. That's way back. Right there it is. So here, tell you what. Pick them on whatever your core, what is that thing called? Core, whatever. So here, your biggest issue, just get rid of all this mess now. Here, I'll drop my stuff here. Your biggest issue here is to find that. So what you have to do is take this function, take its derivative once, square it, and then add 1 to it, then take 3/2 of it, then take the derivative again, put on the bottom. But you're interested in it when x is 30. So what you're doing is rho is equal to, for example, 1 plus dy dx at x equal to 30 squared, and then awful handwriting, but 3/2 over the absolute value of, and that's when x equals 32. That's the big key, is that it has to be evaluated where you're at. Once you've got that, there's your biggest issue, is finding that rho, because then you just take the 25 squared and so if you want to know that, it's 25 squared over whatever you got for that number over here. So whatever that number is what you put in there. Now, he wants to know the direction angle it makes with the x-axis. So the way I would think of that is kind of like this. If you think about it, let's say you got a value that, I'm just making stuff up, so I don't know what the number is. So say it's 5 right here. And of course, he told you this is 3. So if that's 5 and this is 3, it probably looks better like that. Then you're looking at what this is. And now I'm guessing, I don't know this is what he's looking for, but I'm guessing that what he's wanting is, say, that angle. So, I mean, that's a detail that to me is kind of insignificant. But if you want to match the back of the book and you're one of those type people, which I am too. So if I was up here working it in front of the class, I would probably go ahead and do it. But in the grand scheme of things, I wouldn't think it would be that big of a deal. If you can get the AN and the A, well, you're given AT, so never mind that. That's 3. So does that sort of make sense? Now, the only other thing, in 22, he throws something different at you. Here's what he's throwing at you. And I don't know if I've got enough space. So he says And of course, I just put it on there because it was easy to copy both of those at the same time and drop them. So don't get like all bent out of shape if things don't go your way with it. But here, 0.06, and I think that's S. So now your issue is, oh, geez. He's telling you that they got a bunch of mess here. He's telling you this, that the S at point B is 40. So from this, can you tell me what A tangential is as a number? And then what V, this is a stupid thing to say, the V tangential, because there is no V normal. It's always tangent to the path. So what's the speed at that point? Because if you had this and you had this, you just plug them back in the same way you had before. Does that make sense? So how do you get that out of here? Well, AT is pretty easy. AT is just 6 minus 0.06 times he told you it's 40. So just stick in 40 and you're a happy clam and you get a number. And that number just goes over here. How do you get VT? Well, or V, just V. That was kind of I shouldn't have said anything like that. So A is just equal to change in velocity with respect to time, which is nothing more than dV ds. That didn't come out right. ds dt, or it's nothing more than the velocity times dv ds. How about that? Now, I've got the acceleration expressed as a function of s right there. I mean, he gave it to me. And I don't know why I wrote that all the way over there. So if you're looking at this, make sure my handwriting, I didn't do that. V dv. Oh, and integrate. So now, first thing he's got to do, I hope, okay, so when s equals 0, v at s equals 0 equals to what? I hope he said it started from rest. Otherwise, you can't do the problem. Starts from rest. That's very important. Otherwise, if he doesn't tell you it starts at rest, there's no problem to do. So that's a 0. This is the velocity. And this is at 40. So then what you're doing is you're just inserting this term or this equation right in here, dropping it down and just saying 6 minus 0.06 s ds. And if you, I'm running out of space here, but I think I could fit it the rest of the way. And that's going to be just v squared over 2 evaluated at v and v naught, which was 0. And that gets you the rest of the way. So you just perform that integration and you'll get the velocity as a function. Well, let me erase that thing. Okay. You'll get the velocity at s equal 40. Then all you're doing is you're just shoving it back in here. Just like you did right there. Instead of the 25, now you put that in there. That's all there is to it. It's a fairly simple problem. The annoyance is that thing. And then the other annoyance is the fact that you've got to do this. Oops. Try that again. You got to do this. Oh, you can write off the page. Now that's weird. Okay, I got to go look at something. Okay, if I go back over, okay, it's syncing, but okay, let's give it a second. Okay, I'm gonna go look at a page, then we'll go back and look at that page. Oh. So on my OneNote, I made it an 8.5 by 11 sheet of paper. But over here, it's whatever size it wants to be. So I could just, you know, write all sorts of stuff. If I printed this page, it wouldn't show up. But now, okay, this is pretty neat, I think. So you sync it. Okay, it hadn't synced itself yet. There it is. Okay, hang on. Let me go back to here. How do you get the VT? Oh, that's this part right here. No, it's V. It's V from this equation. Here, let me get rid of this. Evaluated from this. So what you'll get out of this, yeah, you take the integral. On this right side, you're going to get a V squared. So you're going to have a square root over this whole thing eventually. I mean, for that matter, it's going to look dumb if I do this, but I'll do it anyway. If I do this, oh, come on. How about that? That'll take care of it. So when you square root the right side, you'll have a V left over, and you'll have a square root of 2. You'll have to bring over to over here and evaluate that. Now this is going to annoy me. Yeah. Oh, okay. There we go. I didn't mean to do that. Okay. And that's it. That's all you have to do there. Now let me look back. I got to see what it does. How long does it take? Yeah, it's not that bad. I mean, it's what, maybe 30 seconds, 15 seconds to sync it. So I know there's also a way, and this is immaterial to you and me, but there's a way you can do this. If we all had a tablet, I can assign a page to each student. They could work it, and it would automatically be turned in. And then there's shared documents. So like if there were a group of people, there's 3 or 4 people could be working on the same problem. That could be weird because one person could be writing somewhere, the other person could be doing it at the same time, and all of a sudden both of them show up on top of each other. I don't think that would be easy to do. So, okay, so let's go back. Okay, now. Okay, I was on the last page. We'll just go backwards. It doesn't matter. Okay, and if I don't finish in this class period, there'll be another class period at 2, and I'll finish it up. So, okay, so it's observed that the skier leaves the ramp at that 25 degrees. If he strikes the ground at B, of course he does, and the initial speed. Okay, what is the speed? Okay, determine the initial speed, which is that, and the speed at which he strikes the ground. Okay, so this is the parabolic motion. And you could put your coordinate system anywhere you wanted to. You could put it right here. If you put it right here, you have one advantage. Let's see, the equations are this. And then y is equal to y naught plus vy naught, or v naught y. I don't know which one he does. Minus g t squared over 2. Now there's velocity equations too, but you'll have to deal with that later. Now there's 2 ways to do this, and I'm always of the mindset, and maybe I'm just getting stuck in a rut and I never get out of it. But I'm fine with that, and that is, as long as I can put my coordinate system here or somewhere in which the thing starts at x naught equals 0, then I'm just going to have x is equal to v x naught t, and t is going to be x divided by v x naught. And then I'm stuck in a rut and I can't get out of it. So then the next thing I do is I insert it here and insert it here. So y is equal to y naught. And if I put this right, if I put my origin where I launch myself, or where the skier launches himself, that becomes 0. T minus g t squared over 2, but then replacing this in that one for that matter, you get y is equal to, okay, vy naught over vx naught. And then you have an x right there, and then minus, you have to be very careful here. Okay, x squared over vx naught squared. I think I did an okay job. Now, this might seem, okay, this might seem like a harder problem than it is, but can you tell me x and y at b? That's supposed to look like an arrow, by the way. It didn't. Yeah. So if that goes 100, I just multiply that times 20, that times 20, and that times 20, right? Okay. Oops. It's got to be 25. Sorry about that. Wait a minute. Wait. No. I'm right. Okay. Okay. Sorry about that. I looked at the wrong number and was trying to add this and make it 100, but that's okay. So this is 80. Yeah. Sorry about that. My brain froze there for a minute. Okay. So I would say x goes over 80. And then y goes over what? Goes down minus 64. Is that right? Okay, so my question is, okay. I was about to say, how can we find this without the angle? But he did. He gave us the 25 degrees. Okay, never mind. Okay, so which one do you want to do? Well, I guess, what is this? Is it meters? Okay, so you got 9.81 over 2. You got x, if I'm not mistaken, that's 80 squared over vx naught squared. But I guess you might as well recognize that, okay, let me get rid of all this, that vx naught is equal to, I'll just call it VA cosine of 25. Vy naught is equal to VA sine of 25. Then you can just stick them in here. VA, which one is that? Cosine 25. Now you got to square the whole thing. So you know what I'm going to do? I'm going to move the square outside of here. And then you get, believe it or not, Vy naught. Vy naught. VA sine 25. VA cosine 25. X was what again? 80. And Y was minus 64. So that looks like to me, you can just, by the way, this cancels that and this becomes a tangent. Looks to me like you could just solve for VA there. Once you solve for VA, you can do anything you want, but one way to do it is you could run back and after you solve for VA, what else did he want? I forgot. Oh, okay. So we've got to find the time that he struck the ground. We need to know that. Well, yeah. I'm, I bet you that he's asking, you'll have to look. This is one of those things where you sometimes look at the back of the book in order to figure it out. But my guess is, let's see if I can get this. My guess is this. I bet you he's wanting to know, here's your velocity you hit the ground at, and you're going to have an X component. Okay, this is really annoying. Okay, this is an X. This will be your X component. This will be your Y component. And I bet you in the back of the book, he's wanting the square root of the VX plus VY squared. That's what I bet. That's what I bet he's asking. And the reason I think that is because when he uses the word speed, so he uses speed and velocity to mean something different. It seems to me, from what I've seen him do, when he says speed, he wants the magnitude. Sometimes when he asks for velocity, if you read it real close, he might be asking for one of the components. And that's something I've observed in his questioning thing, in some of his, what he does. Well, now wouldn't know. Oh, okay. So you're. Oh, now you got me confused because I would think. Oh, well, but I see what you're saying, but I think. Well, okay. So I kind of see what you're saying. So, okay, if you did that, it wouldn't be classified as relative. It'd be kind of, okay, so, okay, if I did that, I had to change colors again. And I'm running out of colors, so maybe green. So you're saying there's this speed, and then component-wise, there's that one. Okay, so I wouldn't use the term relative. I guess normal, maybe a normal, something like that. I bet he's not asking for that. I bet, because really, I mean, I see your point here. When the skier hits, he's going to hit the slope and he's going to immediately head down the slope. What you could do is you could say, if the skis exhibit no friction, what's his speed after he hit the ground? That would be really mean and tricky, but that would be that speed right there. But I see what you're saying, because he's going to have to absorb all that speed. And actually, what's ironic, and maybe you could remind me when we reach that section, depending on how long the impact was, and I might as well do it anyway. This will set us up for this anyway. You know that sum of the forces equal mass times acceleration, but you also know that there's another way to write that. The change in the MV with respect to time. So if it happened over a very short period of time, oops, I wanted to put the dt here, equals to the mass, I don't know if you can see it, times the change in the velocity. So the fact that the velocity changed from whatever that speed is to now he's 0, and that's how much, he hits the slope and he's going to have to do that. I mean, it's like jumping off the building and bang, there's going to be a certain amount of force you have to take with your legs. Exactly. Yeah, and the biggest assumption there, and the hardest thing is, what is the delta time? The best way to determine the delta time is have one of those high-speed cameras, watch the skier, and especially these days, even the iPhone can do like slow motion now. You could find out how long it was that he absorbed it, and you could probably back out, the amount of, he's having to hold himself. I remember years ago, I don't know, you ever heard the word, or a guy's named Vic Braden? He was a tennis coach in Florida. He coached, Connors, Jimmy Connors, all that generation. So he took John McEnroe down there and was doing backhands and forehands. And it turns out that, and what he would do is he laid down a force thing on the ground and they just hit the ball. Turns out that it was 500 to 600 pounds extra in a short burst that they were able to do. So when those guys were doing it, it'd be like, if you think of it, you look at the guy, he's really skinny. He's, McEnroe's only about this tall, really skinny. And you think, how could he press 600 pounds like that? But it's just the way they're, yeah. And so, and you look at it, and I saw the video, and I'm thinking, he's not really trying that hard. And when they got the force off the mat, you could see the little spike. And so it's that delta T is able to get that. So, but he was measuring the force directly, on this pad that they had. Okay, this is all looking kind of similar now. Okay, this one, the ball is thrown. Oh, he tells you the speed. Okay, now this is, and he does give you your coordinates. So he gives you your 2 coordinates. The nice thing, though, is x naught is equal to 0. That, to me, I have to have that. And the reason being, x naught plus bx naught t. If I have that, I can do this, and then I can replace the t. I mean, I like to do it that way. Other people will do 2 equations, and I would do that if I felt more energetic. But the problem is I don't have MATLAB yet on this. I put in the request last week. I tried it a minute ago, and it doesn't come up. However, I do own my own license of MATLAB, and I checked my license, and my license does allow me to use my cell phone on my on their cloud. So I don't know, but I noticed that on I read my license this morning and download the app, and then I was going to do it, but it doesn't do me any good unless there's with the document camera. I don't know. Maybe we'll figure it out. I don't know. You know what? I might put in another request. Okay. Yeah. No, don't do that. Oh, okay. Yeah, there you go. They'll look and see he's never in this classroom. Yeah, but you know what happened is they officially changed the role now. Now I'm official. I'm in here officially. Okay, so I've got that. And so now the process is just the same. Ooh, yuck. What happened? Y. Okay, is equal to y naught plus vy naught t minus g squared, not g squared, t squared over 2. This is in feet. So, I mean, now you just have 80. You've got 20 feet per second. If that's 20, you just multiply that times 4 times 4 times 4. And that tells you Vx naught is equal to what? 12. Vy naught is equal to 16. And the rest of it just kind of follows. You can do the rest. I mean, he wants to know the X and Y coordinates. Okay, so let me go ahead and do one more step or two. Because this is just me. This is the way I would do it. If you want to, you could try it the other way too. Vy naught. Why am I writing Vy naught? I just found it. Okay, Vy naught 16 t minus 32.2 t squared over 2. So you got an equation that sits here like that. But you also know, sorry, talk too much. I guess that's my job now. I can't sit and be quiet. Okay. X over 12. So now you just plug this in and you'll get 16t plus 32. X over 12 minus 32.2. X over 12 squared over 2. So you have y as a function of x. Here. So this equation gives you y as a function of x, but you also have a line here. And you also have, I'm just going to write over this thing. So here is a parabola and the line. So you need to solve, you'll end up solving for this point and that point. And so then the key is what is the equation of that line? If I didn't scratch all over it, I could tell that the slope was the rise over the run, or a half. The intercept was right down here. If that's 20, so if that's 20, that's 10. So that's 10. So the intercept, how about INT for intercept? Is equal minus 80 minus another 10, or equals to minus 90. So then y is just equal to slope x minus 90. Then you equate this one to that one, you'll get 2 points. You'll get this one, then you'll get that one. From there, you'll have, you don't want to take this one. This one's the wrong one. So don't do that one. Do this one. And then from there, you can figure out your t by writing in your x over 12 from right here. When you take your t, you can run back to your velocity equations and find the speed. Did he ask for the speed? Yeah, he asked for the speed. And of course, you know the speed, Vx naught. Okay, Vx is equal to Vx naught. The velocity in the x direction never changes. And then Vy is equal to Vy naught minus GT. So you just take your time, stick it back in there. You'll find your velocity was going up. The G made it slow down, and then turn around and go back down, and then hit the ground. You did all this in physics 1, probably. The only thing you, yeah, the only thing you didn't do is probably those lines, you know. And it's not bad. It's not awful. I mean, it's okay. Whoa. It's hard to see the screen up here, the reflection off the... Oh, another one. Okay. I guess I like those. Did I like them or what? So me, I would put the X and the Y right there. Now, this is a little bit tricky. And I wonder, okay, now I'm a little bit concerned. Because I wonder if he did this right. There's some, what would you be concerned if you looked at this thing? So, okay, so what would you say Vx naught is and Vy naught? Would you say it's 80 sine of 45 and 80 cosine 45? Your first inclination. Okay, now that worries me. Yeah. Because there's that 10. Now, I'm not saying that, but it might, if you find, okay, so how should I say this? Yes, how should I say this in a polite way? Sometimes the solution manual might not, they might have skipped something. I don't know if this is one of them, but I just have this funny feeling that this might be one of them that they might have messed up. I mean, I don't know that for sure, but you're right. I mean, okay, so get rid of that. There's just something that tells me I don't have any evidence. I've never looked at it. I don't think I've worked the problem before. So I don't know. So, okay, so Vx naught cosine, like you said, 55. Sine of 55. So you get two numbers, a number there and a number there. You got your same mess. X is equal to X is equal to V. What did I write that for? X naught plus what? Vx naught. Hey, it's almost time to go. And then Y, you do the same thing. I mean, you're doing it again. Hey, so, okay, so what I'll do is I'll do this same stuff in the 2 o'clock, but I won't do the same problems. I'll tell them to go look at the video. Are y'all fine with looking at the video from them and I could just pick it up from here? And then we'll just do it that way. Besides, one of the advantages of seeing the video is I don't know if you've ever done that. You can click the double speed. And I talk so slow that actually, if you do it double speed, I actually sound like a normal human. And that's kind of disturbing. So, really? Is that about right? I did some promotional videos back in January, and I had a teleprompter, and I had the whole thing. And I look at it, and it's like, wow, that's a different person. Because when I listen to myself doing this, and I listen to myself doing it's a different person. I mean, I talked very fast, very much on point, this and that. I'm like, I need a teleprompter, but then I would have to write the whole thing out, and that sort of defeats the purpose of even being here. Do it from home. Just turn it on. Say, turn on video 2.